The energy costs from computation alone will surpass all other forms of energy in the next decade. The technology that we've developed is designed to overcome that limitation of our existing computing technology and really improve energy efficiency. The problem that we face today is that we keep making computer chips with denser and more transistors, but they've reached their physical limits. With data centers and artificial intelligence and mobile devices, the energy cost of computation just keeps growing. But we don't have a good way to overcome that energy barrier. However, there's a new approach which goes retro, analog computing.
Because we are operating in the analog domain, that allows us to reduce the energy consumption dramatically.
In analog computing, the memory and information processing mechanisms are co-located. So the memory processes the information. Because they're sitting right next to each other, they save a ton of energy.
In analog, you basically deal with continuous signals. In digital, you basically have only two choices, 1 and 0. In digital, 1 and 0 basically is like a transistor, and you use a lot of these transistors in computation. The difference between what we're doing and that is that the information can take any value you want. It gives you increased precision.
Our technology is able to achieve a higher precision by 100-fold than existing state-of-the-art technology, and at least 3 orders of magnitude greater dynamic range than all other competing technologies.
This device uses a different mechanism than all other devices that have been demonstrated as emerging memory devices for computing for AI application. Rather than just storing memory, it can also contribute as a computing element. Non-volatile memory device means that when you program the device to one state, it doesn't change the state even though you turn off the power.
And the way our device works, it works based on ideas stolen from batteries.
Battery is, you can think of it as a memory device. You can charge a battery halfway, and as long as you're not using the battery, it stores that state. Memory devices are elements that we want to be able to program and to have that state remain. ETC RAM is really a way to be able to program and to retain that information for a very, very long time, even at elevated temperature.
Other regular CMOS technology already used for most of computing elements, they cannot survive that high temperature or high radiation environment. But this memory technology can survive that harsh environment.
These devices can survive up to temperatures as high as 600 degrees centigrade. These types of devices are orders of magnitude more tolerant to radiation that one would find in space.
Our technology is so manufacturable, so stable, and so precise that we can tip the value proposition for analog to replace digital and get real industry interest.